variables into factors. Now collected the data. After collected data, you have to do the confirmatory factor analysis. You can do confirmatory factor analysis with the help of many software. AMOS is one of the things. It's called with the help of the SPSS. Usually, you are all people using, but you can do everything with the help of JASP also or Kannada also. Okay. Now here I have given CFA questionnaire. You see that this is one questionnaire. They are given two factors. One is enabler. Another enabler, we have how many items are there? 6 items are there. 6 items are there. All the 6 items are confirming to the enabler. This can be done with the help of the confirmatory factor analysis. Clear or not? This is the only sample. So another factor is also available. That is called as a barrier. That is called as a barrier. Okay. So the barrier has four. Eight items are there. So now all the 8 statements are confirmed to the factor barrier or not. This can be done with the help of the confirmatory factor analysis. Clear or not? So when doing these things, we have some fit measures. For that, I have given there will be some fit summary. This is the fit summary. Your chi-square value divided by degrees of freedom should be less than 5. The first one is chi-square divided by degrees of freedom should be less than 5. The second one, the p-value should be greater than 0.05. P-value means you are telling about your model is a best model. You are comparing chi-square test. That is observed and expected. Observed and expected. Expected is your model is a good fit. You are assuming that. Then GFI, goodness of fit index should be always greater than 0.9. Normed fit index is always greater than 0.9. Okay. So these are the conservative fit index. It is also should be greater than 0.9. But the error value RM SCA, root mean square error approximation should be less than 0.08. These are all some fit measures. At least 5 fit measures must satisfy for CFA and structural equation. Up to satisfy you have to proceed your model. You have to develop your model. So this is the things I have given. So AVE value, that is average variance extracted from each factor should be greater than 0.5. So this is the research paper. It suggests that minimum of the following indices should be reported: model chi-square, root mean square error, or comparative index. Okay. So these are the things you should remember. So I have given everything to you. Okay, shall we do? Now you see that you can do it through or commander also you can do it. Which one is JASP? Now you are all very familiar about JASP. Now JASP. Hello? You open JASP. All of you open JASP. Hereafter you do simultaneously. You note out what are the links, what are the steps I am doing, or otherwise I have given in my PPT also. Just you note down. Now to open file, click open computer. I put everything in my Vijayawada file. So here CFA data. So this is the data. So A1, A2, A3, A4, A5, A6 are 5 variables. You can convert into scale, or otherwise you can take it as it is. But for converting, just click scale, click scale, click scale, click scale, click scale, click scale. Okay. Now, this is the first factor. This is for the first factor. Okay. You just will practice, then only you can enjoy. Now, in the factor analysis, you click this one. Click, there is a confirmatory factor analysis. That option is there. Confirmatory factor analysis. Confirmatory factor analysis. Click, just click on. Now, this is the factor. What is the factor name? You can give factor name or you do enabler or something. So therefore, enabler. Now bring these factors A1, A2, A3, A4, A5, A6. This is the simplest one. But you have to do everything with the help of AMAS. But without using AMAS, you can do it. This is a free software. You are all installed, you know. Otherwise, you have to ask somebody. Now, you come down, model options. There is no need for model option. If it is necessary, we will do. Then additional output. Click additional output. Easily you can get everything. In AMAS also, when you are doing the reliability, that is called construct reliability, discriminant validity, you have to do some Excel calculation. But here, not like this. Additional fit measure, KMO value, parallel test, R square value, AVG, reliability. Everything you can get it with the help of some point and click method. Only point. Click. It's very, very easy. Now you want plots. You want model plot and you want to show estimators. Now just you right click, easily you got it. You see that now here, this is our model. Chi-square value divided by 9 should be less than 5. Here it is less than 5. But P value should be greater than 0.05. Because I have to tell my model is a good model. P is greater than 0.05. But it is not coming. P is greater than 0.05. For that, you have to go for modification indices. You see that CFA value, all you got it. But here, what about RMSE? RMSE value should be less than 0.08. But it is coming 0.116. It needs some modification. So now you go for modification indices. This is the modification indices. I think I didn't click modification indices. If I click modification indices, yeah, model. So modification indices, then only we will get modification indices. You see that the Bartlett sphericity, you reject it, P value. I told you no. AVE is 0.428. Modification indices, if you connect A1 to A2, you are getting high modification indices. How to connect? So you come here, residual covariance. Now click A1 and A2. Sorry, not A1 and A2. After connecting this one, you see that now the RMSE value is nearly 0, reduced. Now what is the P value? 0.667. Here in AMAS you will connect it with the mouse. But here you are getting this value divided by this value is less than 5. But this value is greater than 0.05. My fit measures. I got 2 fit measures. The third one, CFA value. is also greater than 0.95. Okay. Now RMSE value, it is also very least one. Now KMI value, I told you, no, KMI value should be greater than 0. Some overall value is greater than 0.0824. Then P value for Bartlett test is less than 0. So now this is the parameter estimates. Now AVG value 0.47, reliability value 0.815. There is no modification in this. So what this model tells about, among the 6 variables, 2 variables are correlated. Here, 2 variables are correlated. You may keep these 2 variables, or you can remove any one of the variable from the model. Totally, we are having 6 variables. In the 6 variables, A1 and A2 are correlated more. So therefore, you can remove any one of the variables. Which variables are giving least correlation? That variable you can leave. That can be identified with the help of value, this value, indicator estimates. So here, the estimates, here you see that these are the things, A1 and A2. So when you are doing, this is residual variance, not this is the variance. This one, point factor estimates. So here, this is A1, this is A2. This is called a regression coefficient. This is called A2 multiple linear regression. Before that, this one. Which one is the least one? A1 is the least one. If I remove A1, I can get better model. This type of doing is called as a confirmatory factor. Just before going to analyze your data with all the statistical technique, you have to make your data. So from yesterday to up to now, we did only the making the data. It's clear or not? Now I am going to remove A2 to A1. I am going to remove A1. How to remove A1? So therefore, just click and remove. It is a very easiest thing. Now here, now you see that. So what is the value now? So I am having only 5. What is my reliability? AVE is increased. Now we have only 5. P value, MSC value, this value. Then RMSC also least. This is also bigger. All the fit measures we are setting. Now take only 5 variables under dimension of NLR. Out of this 3 analysis, first we confirm what I believe. Then after calculating the prior study, you will do principal component analysis or exploratory analysis. Okay. Now we got a structure of the questionnaire. Now the questionnaire is given to your respondent. Number of respondents you have to say with the sample size. Now you got it. After that one only you have to do CF. First you have to do ACA or BF. It's clear or not? That's why I'm telling stage. Is it clear or not? This is a correct route of doing. Otherwise, randomly you do it. You take 5 variables with one object. This is the perfect. Is it clear or not? You will get a result is perfect. Yeah. Please. Yeah, in the linear regression, this is called linear regression model. In the linear regression model, each variable is least form a dependent variable. That variable is variable. How you can identify? They can identify with the help of the standardized regression coefficient. The least value of the standardized regression coefficient equals least compared to the another. So here I have removed one variable, that is A1. A1 unstandardized regression coefficient is the least compared to other. That's why I know. Is it clear or not? Any doubt? Okay? You have come to an idea. So this is the original procedure. We use this one. First of all, you have to collect the data in person. You have to spend time for collecting data. If you are not spending time for collecting the data, your success will not come perfect. Because you have to, if anybody asks you any doubt, you have to tell. In Google Form, everything, you will have some trouble. So this is called confirmatory factor analysis. Is it clear or not? Okay. So this way we have framed a questionnaire. Now, hereafter you see that I am having this is 6A role description because I have given two questionnaires to you. One is role, another one is called as a job description of employees. So this is the role description. I am going to, this is the 14th test of that. I have given output and output interpretation to you. You listen and simultaneously you try and note down. Okay? What are the interpretation I explain? If I am going fast, time is remaining. Okay. That is also one possibility. The perfect thing is confirmation pattern model is you are assuming that your model is a perfect model. If you automatically took the same kind of a model and compare with the model, then you give the chi-square. So that is the meaning of the CFA. Because every variable should be correlated with some variable. When you are telling, we have 6 variables. When you are giving correlation among the 6 variables, you will find the correlations. But how these are all contribute to the factor? That is the one thing. Then if the 2 variables are more correlated, then only you can. That is the things asking for CF. Simply, if you want to find which one is highly correlated, we first measure of the correlation. And also correlation test of the correlation. Okay, shall we go? Okay? Understood or not? What I did up to this meeting? First, yeah, is. There are certain values. Factor loading, yeah. Which one? CFA. The CFA, factor loading is there. Factor loading is a mean of correlation between variable and factor. Factor loading is a mean of correlation between variable and factor. Okay. So which one is the least correlated? That one I am doing.
Add up to 1.
Add?
Will it add up to 1 always or always?
No. How many correlation they are getting? That's all. In squaring is called as a square root. That only we can give as a variance. I tell you, when we see the multiple regression analysis, understand multiple regression analysis completely, this type of doubts may be clear. Okay. Now, because I have started how to collect the data, first how to frame the data, reliability, then now we come to do statistical analysis. It's clear or not? It's clear? Okay, shall I move? Okay. Now, the two types of analysis are there. One is called descriptive analysis, another one is called as inferential analysis. So the descriptive analysis comprises as frequency distribution and diagram for nominal variable and mean and standard deviation for scale variable. That is called numeric variables. Okay, you know something how to do it, everything. But in JAS, I'm doing everything. Yeah, with the help of R commander also, you can do it. Now I am going to open, you see, JAS. I have given everything line by line in my PPT. Okay, you note down and try you are understanding or not. Finally, I give 1 hour time to you. You ask any questions and where will you verify going fast or something. No. Now you open JAS. Simultaneously, I am going to open many files and explain to you. Because I am going to reduce the time also. Now, this is the JAS. So open, all of you open computer, the file name, enroll data. Because I have given, okay. So the roll data is Excel, you know? You click roll data Excel, open. All of you open. This is the role description data. Because in the role description data, so these are the things are there. What are the things? So this is demographic variables, gender, male, female. These are categories. Okay. So if the cursor is tick this one, you have to put under gender variable 1 for the first respondent. The second respondent is also male, put 1. Third respondent is female, put 2. It's clear. Similarly, we have an Excel sheet. That Excel sheet I have taken into JAS. All of you taken or not? JAS open or not? No. Okay. This is very easiest one. I did how to do everything with the help of Excel and Word. You prefer your own report. Okay, I have given everything. Just you have to edit that's all your data. Okay, it's clear. Now, these 4 variables are nominal variables. Nominal variables, because this is a categorical variable. It has only 2 groups, male and female. Another one is this less than 25 category, 25 to 35, above 35. So if you take the one printout of the questionnaire and note down these 4 variables are nominal. Is it clear? After imported your data in SPSS, first things you have to label for nominal variable. Only for nominal variable. First you change gender as it is nominal, age nominal. You keep the cursor on icon and change. It's clear or not? Simple. 1 second. Keep the cursor on the icon type. Now keep the cursor on nominal variable name and click 2 times. Now come to label. This is called label. Simple. Male. This one you type here. Female. Enter. So close. You see that in SPSS also you have to do like this. So it's clear or not? Next one. What about the age category? Below 25, 25 to 35, above 35. Below 25. So therefore age category 1. Just click. This is below 25. Below 25. 25 to 35. Above 35. Above 35. Click. So now education. What's the meaning of education here? proportional, non-proportional. One proportional. Simultaneously, you try and note down the path. Because I have given everything in my PPT, even though you forget it, you go and get it. So now this is non-proportional. Enter non-proportional experience. Below 5, 5 to 15, above 15. One for below 5. Below 5, 5 to 15, above 15. Above 15. That's all. So this is nominal type, nominal type, nominal type, nominal type. In yes, the nominal type means it is different colors with uniform circumference. Okay. So A team, B team, C team. Three teams are different. I am not given any order. If you are giving the grade, A grade, B grade, C grade, that time you are giving order. A is better than B. B is better than C. That time that is called as a ordinal. It's clear or not? Okay? All of you completed. Okay? Right. Simple thing. See that? Here, what is the first thing I want? Frequency distribution and the diagram. Bar chart or pie chart. You know, in many software you will get it. In Excel also you can do it. But it is the one of the easiest one. That's why. And also you learn one of the software. To get it, frequency distribution and diagram, click descriptive. Click descriptive. Bring all the variables, gender, age, education, experience. Bring all the gender, age, education, experience. These are all four nominal variables. All are being or not, okay? All variable, okay? Now, come down, click basic plots. For histogram, click this distribution plot. Click basic plots. Click distribution plots. For pie chart, click pie chart. Click pie chart. You want any color, then click customizable plot. I have given everything in PPT. Why I am telling means, if you not writing, then you select any one of the mode of this one, color. Then finally come to tables, click frequency table. Finally come to tables, click frequency tables. Okay, you done it, okay? Done it and you note down, or otherwise you see that in my PPT I have given. Why I am telling again and again means, so descriptive, here I am not given just descriptive. Because I did everything in R commander, that's why I am not given. But just also here, parametric. Yeah, here parametric, just non-parametric, just also given. I send you descriptive statistics also. That's not a thing. Clear. Now you see that this way of attitude, how to take everything. Now you see that this is the frequency table. This is the frequency table for gender. In our data, we have 150 respondents. Among 150 respondents, 38 are from male, 62 are females. Got it or not? Okay. Similarly, I have a frequency distribution for all four nominal variables. This is the diagram for bar chart. Bar chart. Bar chart. This is pie chart. Clear or not? Okay. So now you make a use of the Excel, or you can copy and paste. That's not a problem. But it comes, you copy here, frequency table, copy, and open one Excel file, one empty Excel file or empty Excel, you paste it, okay, because it comes like this, that's why you cannot paste as it is. So you take this one, Control C, Control V, Control C, Control V, Control C, Control V. Now write, this is gender, this is frequency, this one is percentage. It's clear or not? Because I need this type of information only. I don't need missing also. You remove this one. Is it clear or not what I am doing? That's the flow. Okay. Now you copy this one. You open one Word file. Empty Word file, paste it. So after paste it, you come here Word, all border, then make it center. This is enough. You are preparing the report of the clear or not? So now similarly, you copy bar chart or pie chart. For two variables, this is simply copy and come to Word file. You paste here. This is the procedure. This is the two things. One is making a distribution table, another one is a chart or pie chart. This is clear or not? Clear enough? Now, you see that in my materials, I have presentation of tables. Yeah, presentation of tables roles. You open 16. This is the research methodology, what you are going to do. So what you have to write, to study about the role description of employees, the author collected primary data from 150 respondents through sampling techniques. Multi-stage sampling techniques by the way of questionnaire. What are the different age group, educational, these are all things. This is what are the tests you are going to use, t-test, ANOVA, treatment, chi-square. You have to explain everything theoretically, what they are given. It is in the third chapter. The first one, this is the analysis things, descriptive. Here you copy and paste. It's clear. So you paste your this one, then write down your interpretation. What is the interpretation? This is the interpretation. From the above table, because we are having the only two groups, one is male, another one is a female. From the above table, 62% of the respondents are from female and 38% of the respondents are from male. So therefore, what is the higher percentage? Males are, females are higher. Why is the females are higher? You have to mention. Because that is called qualitative analysis. This is quantitative, you got it. How many persons are in this one? This is sample data. Okay. So therefore, in this particular company, more employees are from female. Because why? Depends upon the nature of the work or depends upon the area where company is situated. These are all things called as a qualitative. Here. Okay. So similarly, you have to do. I have given perfect output. This is the interpretation. Just you edit and paste. You take, remove this table and the diagram. You put your table and diagram and edit. For the second one, this is age category. In the age category, this one. This is more than 2 groups. For that one, you can use pie chart. So this is the pie chart. This is the pie chart. This is R commander. You can put JASP also. Because this is three categories, that's why you have to say minimum and maximum. So therefore, maximum respondents are younger. Minimum respondents are younger. Minimum respondents are younger. Why? Here, this is the output presentation. Here are, okay. Now, the next one, I am going to find mean and standard deviation. Hold on. To find mean and standard deviation, descriptive, and bring all the variables. Before that, you have to change this variable all scale forward. These are all into, because I am going to add, that's why you make it this one as a scale format. But in JASP, you have to change it into scale. Just only nominal, only you have to give levels. So all of you change. Okay. So you save this data also, save role, the Vijayawada. I am putting this name as role data. Now role is JAS file. So now I need descriptives. So descriptive statistics. So here you bring all the values. Just easy. In R commander also you have to do. Then click transpose descriptive table. Table should be transposed. What are the things you are need? Statistics. What are the measures you need? Just click. That's all. It's very easy. So you are until I need only mean and standard deviation. Mean and standard deviation. That's all. Simply you come to output box. You are having like this. Clear or not? This is we got it mean and standard deviation. Just you copy. Just copy. In the empty file, you make it. These are the things you know, I think. Initially, I am telling. Next, copy, or otherwise you can take it as it is, but you will get one empty space. That's why copy, paste. You make it everything as a 2 decimal. So therefore, here this will be 2 decimal. Now this is statements. Statements mean standard deviation. Standard deviation. Now copy. Now copy and come to your WAT file. This is the empty WAT file, you know. You paste it. This is the easiest way. So now click all border, center. Here, okay, this is the way of handling. While seeing and typing everything, you are getting all the things. You see my output interpretation, presentation. I did everything, but for you only, I am doing again and again. So this is So this is the factors only I given. Similarly, I given this one. This is the mean and standard deviation for all statements. In the place of Q1, you have to copy the statement, not Q1. Everybody cannot understand like this. Understand what is Q1. For that, what you have to do, you take, what you have to do means, this is, where is our role description? This one, you know. So you copy this one. I am able to complete my work. The presentation of table, not this one. So this is this one. In the place of Q1, it's clear or not? Okay, which variable is more important? The first variable is the more important one. We can identify from this which variable is the more important, or because they are given, strongly agree for first one. I am able to work, I am able to plan and complete my work. This is the interpretation, you can get it from this table. Clear or not? Clear? Now, how they are measured our factor, that can be identified when you are adding all the question number 1, question number 2, question number 3 and question number 5. These are all put it into work related data. Work related. Are you follow or not? Yeah. So you see that this is my questionnaire. These 5 questions are under work related. Each individual measured each statement. That is different. How they are measured? All are measured. The first question is above average level. 4.12. You know, strongly agree the statement. Averagely, the respondents are agree that particular statement. It's clear or not? Now, how they are measured? Work related concept. For that, I have to add Q1, Q2, Q3, and Q4 and Q5 and put it into one new variable. How to do it in this? Okay. Now, listen, just to make it a new variable, you come here, data. Here there is a plus sign is there, plus. For getting new variable, click plus. Very, very easy. Click plus. Now type new variable name, WR. New variable name, WR. Type new variable name, WR. And click create column. Click create column. You see that new variable has come here. So create column. Now we got the new variable. New variable. Now, after getting these things, this is the function. Just you click this one 2 times, you will get a box like this. So here you are going to add 5 variables. For adding the 5 variable, you need 4 plus sign. Q1 plus Q2 plus Q3 plus Q4 plus Q5. So easily drag this one. Click 4 times. 1, 2, 3, 4. Now you take with the help of the mouse. Whenever you are getting green vowel, leave it. Q2, leave it. Q3, then Q4, Q5. That's all. So when you are practicing, you can do many. Okay, just here. Q1, Q2, Q3, Q4, and Q5. So therefore, now you click compute column. Now you see that you got the values. You got it or not now? Simple way. Okay? So now because that is actually Excel also very one. It is Microsoft Office. But JASP is a free. When you are sending your paper with the JASP, you can quote it. I use JASP 0.18.3 because it is a free and open source. When you do everything in SPSS, you have to go which version you use, how to what everything you have to tell. But here it's not necessary. It's clear. So daily you can update also. The new version comes, you can download the new one and you can use it. Similarly, you try add all. What about second one? Second one is role clarity, RC, role clarity. So therefore click, because you will get an experience. So therefore role clarity, click. Now come to here, click this one. So therefore click, click, click. So Q6 to Q10. Q10, conclude column. Now, another one. What is the third one? The performance related, PR. Performance related. So, come to Q11. Q11. Q12. Q13. Q14. Q15, compute column. The next one, GO. GO. So you add 16 to 20. $16, $17, $18, $19. That's all. Now, how they are measured? Total role description. Each one measured. There are all. Okay? That can be identified adding all the 20 variables. Instead of adding all the 20 variables, I can add 4 created factors. Because each factors are sum of the 5 variables. Clear or not? Okay? So therefore, now total. This is total. Total. So we are adding only 4. Therefore, I am giving 3 plus. If you want to remove, just you keep and click here. This is the dustbin. You can put it into dustbin. Okay. Always, if you want to bring whole means, you take this one. Now, WR, RC, PR, CO. Now, you see that I am having all the new variable. New 5 variables are scale variable. These variables are scale. WR, RC, PR, GO, total. Clear or not? Okay. So if you know the many softwares, which one is feasible to you, you can do it. That's all. Okay. You can mix. Now I want to find mean and standard deviation for all factors. How they are measured, each factor. Mean and standard deviation. So therefore, click descriptive or you do the same descriptive. Now, WR. Okay. Now I want mean descriptive table. Statistics. I want mean and standard deviation. Simply you see that here you are getting. That's all. Copy and paste. Now you know how to copy and how to edit. It's clear or not? Now you see my presentation of table. So this is the things. Now you have to write your interpretation. I have given you the interpretation for each one. So mean and standard deviation. Based on mean score, which one is the highest one? WR is the highest one. The next highest one is the RC. Therefore, WR and RC are the most important factor. You do this one. Road description data. Here I have written 68.67%. That means in normal distribution, the concept is that this is normal distribution. This is mean. Okay. Here this is called mu minus sigma. This is called mu plus sigma. Under this area, we have 68.67%. Now mu minus 2 sigma. This is called mu plus 2 sigma. So this area is nearly 95%. That's why it's called as deviations. So now here mu minus 3 sigma, mu plus 3 sigma, that is 99.97% of the observation. So therefore, now for example, what I did here, total 73.63 minus 11.63, what is the value? That is 62.2. 73 minus 11, 62, 63 minus 1, 62.2, mu minus sigma. When you are adding these two, this is called mu plus sigma. That means 68.67% of the respondents are given their opinion within this range. Clear or not? This is the interpretation you can write with the help of the mean and sigma. And also you can find among the 5 factors which one they are given more response. Clear or not? With the help of this one you can do it. Clear? Okay? Now, for the next one, I am going to find how they are each measured total description of the data. Low level or high level or moderate level. I am going to create a new variable with the help of the scale variable. New variable should be the categorical variable, contains low level, moderate level and a high level. For that I use one method that is called as a quartiles. Quartiles. How to find quartiles? In the same description, you can find quartiles. This one. This is, here, if you put quartile, you see that the total Q1. What is the Q1 value for total? You have to do for all the variable, but I am explaining only for one variable. Q1 65.5, Q3 81. So all the 150 respondents are given their response for total variable. How they are measured? We have the column. Clear? So those who are given their opinion below 65 point, that one, below 65.5, I am putting that in group number 1. Those who are given their opinion above 81, I am given for 3. So the remaining I am going to give the number is 2. It's clear or not? Just I am grouping. You are below 50 marks, you go there. You are 50 to 60, come here. Okay. So that's the way I am going to. So I am going to create a new variable. That variable is called as a level variable. So in just how to create. In a programming language, you have a if condition. This is condition. If it is okay, then this is yes option. If it is not okay, this is no option. In programming, okay. So therefore, again, you have a multiple ifs. This is called as a multiple if. So yes, no. Similarly, we are going to do simple way. You try because you are learning something new. That's all. Now, how to do the things? Now, to create new variable, click level, create column. New variable, level, create column. Click. You listen, then read whatever I am doing. You just listen. We will do 2 or 3 times. Okay. Now, in the drop-down menu, you are having so many options are there. Hereafter, you can enjoy what are the options you need to go and enjoy. Just I motivate you. That's all. Okay. So now downward. Here if else is there. Okay. You bring this one and leave it. Here also I am going to have another if else because three conditions are there. You know, you put this if else here. That's all. Now here test the total is less than or equal to 65. So you bring less than or equal to. First you bring inequality. Inequality less than or equal to. So now you bring total. Now you bring total. That should be scale. Now what is the value less than or equal to 65.5? If the 65.5 I am putting 1. Next here greater than or equal to the total value greater than or equal to 81. I am putting them into third. If you are dividing by equal 10 means that points are called as deciles. 100 times you are dividing equally means percentile. So 4 times means that is called as a quartiles. Okay, clear or not?
Okay.
So now the we take after we call the quartiles in discrete units. We call when percentile between that 70. Or it's like 2 3 columns we call. So for W I saying 16, 20, 21.
Yeah. 16 is the first quartile. Second which one? For G is now. So which one this one? WR Q1 is 16, Q3 is 21, median is 20.
So what is the for this
Total, you are not included the total. You bring total there. Because I did for only one variable. Okay? So I did for total. If you are doing your research work, you have to do for all the variables. Like this. Okay, so now, or else you take this. Okay? Now, you bring this one. Okay. Three, two, clear? Now we created a new variable. That variable is in the form of a nominal level. Okay. No, 58 means if you want to divide into two equal parts, then that is called median. Now I need three different categories. One is low level, another is a high level, another is a moderate level. The for that one I am taking one measure. That measure is called as a quartile. Alright, okay, right. Okay, it's clear. Now, so now this is a we got it level. I think I can we come to so the level, how to do it? So this one, compute column. You see that computed, 1C something. Now I'm going to make it as a nominal. Make it as nominal. Now what is the meaning of one? You give label editor. The label editor, this is one for low, two for moderate, three for high. Yeah. Now come to my output presentation. You have to write like this. Quantiles of row description of respondents. Q1 is 65.5. Q3 is 81. This is the median. I have written everything. These are, I think, this is the table. Then this is the diagram you have to go. Clear or not? Up to this called as a descriptive. Okay. Next one is called inferential analysis. How are doing now? Huh? Okay. Okay. This is something. Yeah. I will put here one. Then we put one. One, take one. Then in the else part we bring again pairs. Okay. Now you put Federal person. Bring Federal person. Now give total here. Variable further. Put the value. What the value? Put the value. Come with it. Now type 3 in the zone 1 3, then just 1 2, then come to the one. Click on the one. Okay? One choice of clustering. You can apply clustering. Clustering technique also you can apply. This is the simple one I believe. Whatever way you are going to divide, you can divide it. Okay, I have taken one measure, that's all. That is so now you bring less than or equal to 10%. Right? So now bring to what the value we have, Q1 value. Okay, Q1 value. 65.5. Right? 65.5. Okay, then 1. Type 1. Now we bring greater than or equal to. Okay, now bring product. Total. Now type 8. This is 3. This is 2. So now you are getting the existing. Otherwise, it's 2. That's all. Okay? Less than, greater than. In between those who are having that. Clear or not? Up to this clear. So with the help of jazz, we are doing very, very simple. Very simple thing. This one. More than ever. Because here we have I mean only for water. How they are measured W1, RC, GO. These are all you can do. It's clear. So I did for only one variable. You try for another 4 variables. Up to this called as a descriptive analysis. Shall we move for differential analysis? Yesterday I told we are having 14 tests are there. Just I explain and interpret. I hope you are all know I explained yesterday. It's clear how to do it and how to interpret it. That's the only thing I am going to tell. What are the tests you are going to use? That's what I told yesterday. Now how to do it, I am going to tell today. And interpretation also I am going to do today. It's clear. So you take my output interpretation and just you edit it. That is enough for your data. Clear what I am telling? Huh? What are the even necessary material you will do it? Statistical part only, my part in these things. Okay? If you are having any doubt, you ask me. That's why I am opening everything and doing one by one. Now, the first statement is you have to do for every statement. So the first thing is I am going to do for test for single mean. I told yesterday, if you are having a only one variable, that variable is a scale variable, then you can go for test for single variable. So your null hypothesis is the particular statements are equal to average level. They are measuring average level, 3, neutral only. With the help of the samples only, we have to decide they are measuring below the average level or above the average level. Clear or not? Here we are going to take only one variable. That variable should be a scale or ordinal. Scale or ordinal. For the question there, this is ordinal converted as a scale. So I am going to do it for all 20 variables. How to do it? Simple. Just you listen and understand what I am doing. To go for t-test, everything is available. T-test. Under classical, one sample t-test. One sample t-test. You bring, I am going to do for all 20 variables. I am going to do for all 20 variables. Simple thing. For test value, your assumption is average. That's it, 3. Why I am putting 3 means 5 for strongly agree. 5 for strongly agree. 5 for strongly agree. 4 for agree. 3 neutral. 2 disagree. 1 for strongly disagree. What is the average? 15. 15 divided by 5 equal to 3. Therefore, my average mu value I have taken as 3. So this is my H0. This is my H0. What is my H1? H1 is mu is not equal to 3. Clear? Okay. So next thing you click descriptives. Click descriptives. Because in your output box, what are the things are necessary? The statements. The statements, that is Q1 up to Q20. then mean, standard deviation, p-value, 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 p-value. These four columns are necessary. Gas will give easy output. All the 20 you can get it. So therefore, you put the value of 3 in test value. Then descriptive. Now you come to your output box, come to your output. It's clear getting or not? Just you copy. You see that? The easiest way. Copy Excel. Very, very easy. This one. Copy Excel. Now the copy all statements column here itself. Then take mean value. Copy mean value. Then take standard deviation value. Okay. Now you copy the t value column. No need to type. Okay. Now you copy t value. Paste here and copy significant. Everything is given. Okay, this is statement so and so, so and so. You see my output interpretation. This is my output interpretation. Q1, Q2, Q3, everything. You know, mean, standard deviation, p value, and the p value. It is less than 0.001 means double star. It is less than 0.05 means you put only 1 star. Because double star means it is significant at 1% level of significant, 1% level. So therefore, we reject the null hypothesis at 1% level. Because my p value is less than, this is for interpretation, that's all. P value is less than 0.001. So we reject the null hypothesis at 1% level of significance. Hence we conclude that there is the above statement is not equal to average level because we are rejecting null hypothesis. So that means what things you have to take? Not equal to. It's clear or not? It's clear? You are rejecting mu equal to 3. That means which one I have to take? Mu is not equal to 3. This is for all the statements. This is for all the statements here. So I have given how to interpret also. Since p value is less than 0.01, the null hypothesis is rejected at 1% level of significance with regard to reach the carrier code of employees. I have given for one statement. Then when compared to average level, what is the mu equal to 3? But here sample mean is 4.12. It is greater than. That means it is above average level. Clear or not? It is above average level. This is the test for single mean. Clear? The same, yeah. Significance of the t value. With the help of the t value only we got a t value. I got yesterday my z value. Z for the large population. Z for large population, P for small population. So whenever this increases, it comes to the large population. T value is coincide with the Z value. Here or not? I draw the diagram where the point Z comes. From that point you take the value area. That value is called the P value. Here or not? With the help of the T only we got P value. That's why we are mentioning T and P value. It's clear. Okay? If you are Z value equal to 1.26, your P value should be greater than 0.05. If your Z value is Z or P value is 2.33, that means it is less than, it is greater than 1.86. So it comes in the rejected area. Clear or not? What I am telling you. Okay? Understood or not? Okay, this is the first one. You see that I have given parallelly to understand everything in my questionnaire itself. Now you see that this is first one. This is reach the carrier goal. Is my variable. It is scale. It is a scale. The next one, I have test whether significant difference between gender with regard to factors. With regard to factors. So therefore, gender is a nominal variable. Factor is a scale variable. Gender has only two levels. One is male, another one is a female. I told yesterday. When you are having the two variables, one is the nominal with the two levels and compared to scale, then you can use for independent t-test. Here are not independent t-test. So what is the independent t-test? If there is any significant difference exists between male and female. That is what is the null hypothesis. There is no significant difference between male and female with regarding their opinion about some factors. What are the some factors are there? Opinion about the WR, RC, GO, PR, and total. These are all my scale variable. Clear or not? Clear? So, if there is any significant, they are given their opinion about some particular dimension. Clear? So, therefore, this is called as a independent t-test. Shall I move? Independent t-test. You understand? And given that, I have given every interpretation. Simple. Yesterday, I myself told, if the p-value is rejected, you have to do like this. Accepted, you have to do like this. That is the things only. You see nicely one by one. Now, how to do t-test, independent sample t-test, dependent variable, that is, these are all called dependent variable, WR, RC, PR, GO total, grouping variable, gender. So, simultaneously you can do. So, this is for parametric. When you want to for non-parametric, just you click man writing. Okay? Simultaneously you can do. For parametric, that one, if you are want to do for non-parametric, you click man writing. Clear? Okay? Now, this is the effect size so and so for selection of the test, not descriptive. Click descriptive. Okay? So, therefore, this is 0 because there is no difference between two. Now you got t value, you got it, mean and standard deviation, you got it. Just you copy and paste. Clear? Here we got some information. Now after this one, I put it into my table. You see now here, this is the table. The t value. This is the t value, this is the t value. Okay? So what is 1.94? What are the values are there? Roll clarity. Are you getting same value? RC 0.53, but here different. So therefore, what you have to do? Copy, paste. So therefore, simply you copy, paste, copy, paste, mean value, copy, paste, standard deviation, copy, paste. Okay, now come for this. So there is an option is there, that's why. Paste. Okay, now copy, paste, copy, paste. Now therefore you cut and paste. Okay, now so you make it as absolute, or otherwise you take this one and come to your word file presentation. small border. Okay, before that, if you are introduce one row, you introduce one row. So therefore, this is factors. This is factors. Gender, mean value, SD value, T value, the P value. Okay, simple. You can write your own table. So this is different, I think. Job description data. Correct. Now you see that the first one, you have to, this is double star, this is also double star, this is single star. Double star, out to your interpretation, you have to write, here is double star. So therefore, double star, because significant at 1%, there is no star. So therefore, this is less than. So therefore, P value is less than 0.01. Null hypothesis rejected at 1% with respect to WR factor and row description data. Hence, there is a significant difference between male and female with regard to WR in the row description data. Based on mean score, which is the mean? Which one is the higher? Female is higher. So therefore, mean score, the female employees have better opinion in WR than male employees. You have to give your own. Clear? But while they are telling about second one, RC, there is no significant difference. For PR, there is no significant difference. Here, significant difference exists at 5% level. Here, significant difference exists at 1%. Clear? This is the test is called independent. Because I have motivated and I have given how to write. So, but the T value should be absolute T value. You remove minus sign. Is it clear or not? Okay. So T, this is test for independent T test. Next one, we can move for, or otherwise, what are the things here I have given? Mean of two factors. That means paired T test. Paired T test. How they are measured WR and RC. I told you no. The two variables are scale variable. Then we can go for paired T test. Clear? So how to do it? Hereafter you see how to do it. I have given interpretation everything. Just you recollect it. It's enough again. Clear or not? Clear? Okay? Because I am everything I put in the table. Just you have to do it. So therefore click T test, paired sample T test. I want WR and RC means you bring WR and RC. Okay, so descriptives. So this is for non-parametric. Wilcoxon signed this for non. If you want non-parametric, you click this one. If you click this one, you will get both measures. You see that. So the first one is for T. Second one is for Wilcoxon. Okay, in my presentation also you see that this is mean and standard deviation. What's the P value? There is no significant difference exists in parametric and also non-parametric. You see that presentation 0.8142. Yeah, 0.8142. Okay, P value 0.47. Clear or not? But here WRPR there is a significant difference at 5% level of significant. Clear or not? Simple thing. What are the tests you are going to do? How to interpret? Never ask anybody. This is the thing you have given. Okay, the same parallel test. You know, I told you no. The parallel test. What is the parallel test? This is the first one, the second one. This one, man Whitney. So there is a this one, WR, and if you are putting WR on, so this type of test is called as what we did now. That. Okay. Next. So I hope. So this is the third paired T test. Now I want one way ANOVA. One way. I will follow that. One way ANOVA. One way ANOVA means we must have two variables. One is nominal, other one is a scale. Nominal must have more than one category. More than one category. Okay. So therefore, age group. Here we have three categories. So what is my null hypothesis? My null hypothesis is H0 is there is no significant difference among their opinion about WR, GO, PR, so and so among three equal. Not all are equal. Not all are equal. How to do? Click ANOVA. Click ANOVA. 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 Okay. You take one by one. So I take total. Only one I explain. Total. Total. The fixed factor age you bring here. Clear? Age bring here. Now you come to post-hoc test and bring age here. Then only you can get post-hoc test. Post-hoc test means that you see that there is a significant difference exists among age categories when they are given their opinion about total description of rodent size. Okay, but which one is different? So now you are reject this one. That means not all are equal. This pair may be not equal. This pair may be not equal. This pair may be not equal. Which pair is not equal? That can be identified with the help of the post-hoc test. Here. Okay. So you see that in the post-hoc test, you have to take F value, P value. And in the post-hoc test, you see that when comparing below 25 and 25 to 35, your P value is greater than 0.05. That means there is no significant difference exists. Understood or not? But below 25 and above 35, your P value is less than 0.05. That means, what is the things? Now, mu1 equal to mu2 is accepted. But mu1 equal to mu3 is rejected. Because the P value for this one is less than 0.05. We reject H0 at 5% level of significance. Clear or not? But comparing 25 to 35, that is 25 to 35, P value greater than 0.05. That means we do not. Okay. Because from the F test, we observed here. What we observed here, we are going to reject this one. You are rejecting this one means not all are equal. Not all are equal. Three pairs are there. This one, and this one. So these three pairs are there. Now they are comparing post-hoc comparison below 25, 25 to 35. When come to the P value greater than 0.05, that means we do not reject. We do not reject. So we do not reject. But second one, below 25, above 35, it is less than 0.05. So we reject. We reject at 5% level of significance. Clear or not? So this is the way you are interpreting. This is called as a post-hoc.
So we can reject.
No, not like this. Opinion. So what we are concerned, this means the opinion regarding total description of our data between these two groups are no significant. Not you are rejecting the variable, you are rejecting the statement. Understood or not? You are rejecting the statement. What is the statement? The opinion regarding role description of data between this group and these groups are equal. That is our statement. You are rejecting that statement means there is a difference exists between these two groups regarding their opinion about particular variable. Is it clear or not? Understood or not? Otherwise, you ask question. Okay? Statement. Uh, no. Usually, we are assuming that null hypothesis is neutral or non-commuter. That means equal. I told you no. Mu equal to 3 average. Both are same. This is my null hypothesis. What are the things? Your problem is you are assuming that you are thinking that this should be greater than this one or this should be greater than less than this one. This is called researcher hypothesis. You are going to test this one. This is the neutral one. Any questions?
We'll wait for teacher.
Yeah.
Then we come
Yeah.
back. I will.
Okay. Right. Okay. So now, okay, right. Okay. So now this is ANOVA. ANOVA is we have two variables. One is a nominal variable with more than two levels. Another one is a scale variable. I hope you understand this one. So what is the, how do you interpret? So the interpretation as given here. I've given, this is the ANOVA. So our total description, this is the final things I did it. But you have to put like this. Because here, see that there is no significant difference between these two. That's why I'm putting AA. There is no significant difference between these two. That's why I'm putting BB. But there is a difference between A and B. With the help of these letters, easily they can identify. Clear or not? So these type of, so I did only for overall. You can try for all remaining variables. So this is called one-way ANOVA. You understand it or not? Which one? A, B, something. So you see that here we have overall total description. So this is group less than 25. Another thing is say 25 to 35. Then above 35. Three groups are there. So there is no significant difference between these two. That's why I'm putting AA. There is no difference between these two. I am putting BB. But there is a significant difference between A and B. It's clear or not? With the letters, easily you can identify. These two groups are having same letters. That's why no significant difference. Clear or not? That can be, should be, you have to specify in the output. It's clear or not? Okay? But you see that here, P value is greater than 0.05. That means there is no significant difference among all groups. I didn't put any letters. Here you see that it is highly significant difference. Highly significant difference. What we observed, there is no significant difference between these two groups. But significant difference between these two, and these two. Because here B, B are same letters. Clear or not? Letters you have to write. You have to write with the help of our output interpretation. Clear or not? So this is called one-way ANOVA. In one-way ANOVA, you are having only one nominal variable, one scale variable. Now let us move for two-way ANOVA. Shall I move? Okay? So everything is I am given. That's why I am doing all tests to you. Otherwise, we will rest it. Okay? So therefore, now what is the two-way ANOVA? In the two-way ANOVA, the same ANOVA, you put two variables, two nominals, one scale. So therefore, in the dependent variable, I am taking total. This is in the fixed factors. I am using two, gender and also age. Other things are not necessary. Then you see that we have three hypotheses. What is the first hypothesis? There is no significant difference between male and female. There is no significant difference among age category. But there is no interaction effect. This is our null hypothesis. Three null hypotheses you have to write. But we do not reject the first one, but we have to reject the second one at 5% level of significant. What we observe that there is no interaction effect is there. There is no interaction effect is there. But there is a significant difference exists only among age categories regarding their opinion about total. Clear or not? They are given some opinion about total description of our data. Is it clear or not? So this is called two-way. I have given my interpretation also. You see that go through. This is the thing. You see that 3. I have given for WR and I told you. I have given. The 6th one is correlation. Correlation between the variables. Here we have to take the correlation for, these are my factors. WR, RC, GO, PR. Don't take total. Because total is the sum of all the values. Whenever I got high marks in subject 1, definitely my total increases. If I get low marks in subject 1, my total will decrease. There will be a correlation. But I wish to find the correlation among these things. How to find correlation? And also in hypothesis, the test H0, you are assuming that there is no correlation between two variables. But when you are rejecting, this means there is a relation between two variables. This is called test. Clear or not? Okay? Right? Now, correlation. How to do correlation? Click regression, correlation, you bring the variables WR, okay, so that's all. If you want confidence interval and everything, you just click, otherwise this table is enough. So therefore, GO and PR are strongly positively correlated because 0.744. That means if they are given their opinion about GO, they are also given same type of opinion about PR. Here. Okay, whenever what is the meaning of correlation? Positive correlation. One unit increases in the X, Y also increases, same, positive direction. Decreases, both are decreases. So therefore, the positive sign implies this thing. So the P value also reject the null hypothesis. What is the reject null hypothesis? There is no relation between two variables. Clear or not? This is called as a correlation coefficient. So the output, you see that the output, the correlation coefficient between WR and RC is 0.65 indicate when squaring 42.25% of the positive relationship between WR and RC, not 65. When squaring R square, I tell you what is the meaning of R square, multiple R square. Clear or not? Okay. So already I mentioned this 7th one is a non-parametric. Test for single mean. Here test for single median. The same concept, the same way. If you put non-parametric, the same things. What we did here, you know, we did one sample t-test. The one sample t-test, if you do it for non-parametric means Wilcoxon. This is the 7th one. Here, this is the 7th one. So you will get the value of that one also. One sample t-test. So you see that you take this one and this one. That is 7th one. For 8th one, I told you. 8th one also for non-parametric, independent sample t-test. So in the independent sample t-test, if you put man whitening, this is the 8th one. So one way ANOVA, critical Wallis. In the one way ANOVA, so ANOVA, you know, in the ANOVA, if you are writing come to non-parametric. You see that non-parametric. If you click this one, this is called Kruskal's-Wallis. This is called Kruskal's-Wallis. You will get an idea. Kruskal's-Wallis. This is chi-square value and the p value. So these are the tests. So I did it, this one, 8th one. For paired t-test, there is a parallel. This is Kruskal's-Wallis. So correlation. The same for correlation. Correlation we did finally, you know, the same thing. So in the correlation, if you click Spearman, this is 11. Clear or not? So if you know how to do it, it's not. Now you completed 11 tests. You know when to use. Two variables are there, one is scale and another is a nominal. Then you solve. Clear or not? 11 tests are there. You imagine and you take your data and apply. So now, next one, the 12th one, it is called as a Spearman correlation. This is the 11th one is called as a Friedman. Not 12th one is that one. Friedman test is you are non-parametric. You are assuming that these four variables. What are the four factors? Four factors WR, they are given opinion RC, GO, PR. Your assumption is mu1 equal to mu2, null hypothesis. There is no significant difference of opinion exists among four factors of the respondents. Clear or not? Repeated data. All the 150 members are given their opinion for WR, RC, GO, PR. So these type of checking is called as a Friedman test. This test is called as a Friedman test. So therefore, how to do Friedman test? Friedman test in this one, you see that ANOVA, note down, repeated measures ANOVA, repeated measures ANOVA. Yeah, you see that this is level. What are the variables are WR, RC, PR. Just you have to type here. You have to type here WR, RC, PR, then GO. Now you come here and bring the variable WR, RC, PR, GO. Then descriptive statistics. Now non-parametric, come to non-parametric. Bring this value to this. Now you have to take the value of this value, chi-square value and p value. In the output, you have to write this one only. Chi-square value, p value. Easily you can get the median value. By descriptive analysis, you can get the median value for each factor. So therefore, there is a significant difference exists, their opinion about all four factors. Is it clear about? You try, and you imagine if you are having your data, just you take it and do it. The last two tests of chi-square test. Chi-square test. I told you if you are having only one nominal variable, then that is called as a chi-square test of goodness of fit. So here, what is the 13th one? Because I have given everything here. You see that level of role descriptions or implies are moderate level. Level is a nominal variable. It divided into three categories: low level, moderate level, high level. Okay, low, moderate, high. So therefore, if you want to check this one, you have to use like this. So therefore, here go to frequencies, multi-nominal test. Multi-nominal test. What is the factor? Level. You keep level, then it is a equal proportions. It's enough, no need of descriptives. Then you see that you take this chi-square value, p-value, it is enough. Chi-square value, p-value and observed value. Chi-square, p-value, then observed and corresponding probability, p-value. Therefore, not equally spaced. So therefore, this is you have to put. So if it is a ranking data, I told you least mean rank is the best one. So I told you, whenever ranking, the median value, Friedman test. So therefore, this is the level of opinion, frequency, percentage, chi-square, this one. So therefore, not equally distributed. So this is for goodness of. The final test is independence of attributes. Two nominal variables. You take any two nominal variables. There is no association between gender and the level of opinion. Gender is one nominal, level is another nominal. So therefore, how to do it? 14. Then frequencies, contingency table. Frequencies, contingency table. Gender and the level. Okay. Now, if you want option, you can go option. Anything that's not there, it's enough. Now you see that p-value. Therefore, there is no association between gender and the level of the opinion. You put this one. So these are all the things I have given. So I completed 14 tests. I give you 15 minutes time to recollect it. Or you take half an hour also. I am sitting here. Not any doubt regarding this one, you ask. Okay? You keep your mind free. Because I did 14 tests. Afternoon I will teach regression. Because I completed the main thing. Then we go for structural equation model. It's fine now. Multiple regression, structural equation model. Afternoon. Now I explained the 14. You recollect it. So if you are having a doubt, you ask me. Just I am sitting here only. Because again I am teaching it, you have to listen. You take your data and ask anything regarding this one. I am ready to. Okay. How to do everything in JAS also. What are the files I open? I open the PDF, PPT, Word file, the Excel file, everything I open. Just you recollect. Just practice. If you are facing any problem, call me. Just check my files. What are the files I sent? Check. Completed. Which one I happy to see. This population increases, that population also increases. This is the same mechanism for okay. Here also no relation between because I'm seeing that all the three lines are like this. Therefore, community is present. Community is present. No relation between all of the four. Correct. Which is things becomes here also no relation. Maternity and child care is a no relation. But here this is NGA and negatively that means negatively
So this way we have a prediction.
yeah.
So for example, right, we have the which cell has more value or motivation and but yes.
So that is
And for validating
that can be.
Skateboard oriented.
understood or not? Clear enough?
Character of the data set.
Yeah.
That is ordinal. I have to choose this ordinal shapes for my.
Yeah, that is given in my table.
Exactly.
That table is not. See, yeah. There is not. Only nominal. You are going to just go for x. Otherwise, you can go for.
Whatever is given as
You want to do non-parametric, do non-parametric. Otherwise, you go for parametric. That's all. So before that, I did so many things that is like often we will see multiple linear relations. Multiple linear relations. Then structural equations. Then what are the things you will cover? You will complete and you ask anything. Right. Multiple linear relation. Then structural equations. So, again, it's all.
Do you have any more questions? Should we break? Yeah. We'll meet back at 2. To be here.
To work. 2 o'clock, we will see multiple linear relation. Okay. How to do it with Jazz. I hope Jazz will be helpful to you. Huh?
We can. Yeah, it's actually easier than.
Yes. Because every output are coming in easily. Whenever you think automatic output comes.
Waiting for the timeline. It can. That's it.
You can minimize it.
Yeah.
Minimize this. And,
System will be there.
yeah, okay, no problem. So, disconnect this.
चाबी इधर ही होगा चाबी यहाँ है नीचे देखो चाबी लास्ट में
Usually, variance of y is the formula 1 by n into sigma of yi minus y bar whole square. This is called variance. This is called variance. How much information I am having? I am going to share it to you. Okay, that is called shared variance. Now, so the variance of y hat. Variance of y hat is the meaning of 1 by n into sigma of yi hat minus y bar whole square. So this is of variance of y hat. So y hat is predicted to our independent variable. So when I am dividing this one, sigma of yi hat minus y bar whole square divided by sigma of yi minus y hat whole square, this is called as r square. This is called as a r square. That means among the dependent variable, how much variables are affected. So therefore, you see that your r square equal to 0.89. You got the value of r square equal to 0.89. That means 89% of the variation percentage when dividing. When dividing this one, 89% of the variation captured through our model. Our model means our independent variables. Clear or not? What I am going to teach here, that can be obtained with the help of so many components. Some component may be not accounted for that. It's clear or not? So therefore, 89% of the variation of the dependent variable can be captured by the independent variable which are be included in our model. Something we may not be included. Okay, so my independent variable contributes only 89% of the variation for dependent variable. It's clear or not? So this is called multiple R square. Multiple R square. So another one is called as adjusted R square. Another one is called adjusted R square. There is a formula is there 1 minus R square divided by n minus 1 divided by n minus p minus 1. P is number of independent variables. N is number of observations. Number of observations. Capital R square is a multiple R square value. So you will get the value of adjusted R square value. But adjusted R square value tells about the noisy variables. Noisy variables means in our model, I took y as dependent variable, x1, x2, x3, x4, x5 as independent variables. So when I am applying all the 5 variables in my model, my adjusted R square is, I am getting 78%. If I am removing the noisy variable, means the variable does not contribute anything for my model, I will get 84%. So whenever you are including the noisy variable, that means the variable is not giving any contribution to our model, your adjusted R square value will be decreased. So the useful variable you are introducing, adjusted R square value increase. These type of methods are called forward and backward methods, so on so methods are there. Okay, so this is called simple linear regression model. So in the regression model, we have many outputs we will get it. What are the outputs you can see means here, what are the things I told you now. So here, root mean square error. Root mean square error. I told you error. What's the meaning of error? Y minus y hat is called as a error. So what is the root mean square? Square y minus y hat. When squaring, mean means you add all divided by n. This is called mean of the error. Means clear error. Mean of the square error. When finding the root, this is called as a root mean square error. So root mean square error tells about average deviation, average error we can predict. In my model is so and so. Average error predict in my model is so and so. That is called as a root mean square error. It's clear. Another thing, each variable you have assumed h0, my beta 1 equals 0. So therefore, if your p value is less than 0.001, you have to reject. You have to reject. So what is the meaning? Y equal to beta naught plus beta 1 x1 plus beta 2 x2 beta 3 x3. So this is called multiple linear regression. Multiple linear regression because we have many independent variables. More than one variable, one independent variable you are having, that is called as a multiple linear regression. Linear regression. Clear? Now, here I am assuming this one. H naught is beta naught equal to 1. Your p value is greater than 0.05. What you can do? Your p value for this hypothesis is greater than 0.05. What we can say? Huh?
We can use hypothesis can be accepted.
Null hypothesis can be accepted. What is the meaning of null hypothesis? Beta 1 equals 0. Beta 1 equals 0 means this variable does not contribute anything for my model. It's clear or not? So concept. Okay. So if p value is less than 0.05, we can reject this one. So that means beta 1 has some value. Some value. So therefore it is significant. Clear or not? So that is the way you can predict your variables are significant or not. Another thing is F test. F test. F test means you are assuming all the variables beta 1 equal to beta 2 equal to etc. Beta n equal to 0. You are assuming all the. So if the p value of the F test is greater than 0.05, all the values are 0 means you are only getting the beta naught. Any variable does not contribute for our model. That means your model fails. Whenever you are getting the p value for F test greater than 0.05, you could not use multiple linear regression for your model. So the p value should be less than 0.05 for F test. That is a compulsory one. The first point you should. Even though R square value is less, whatever you are getting, not a problem. But the p value for F test should be less than 0.05. Less than 0.05. Clear or not? These are the things you have to keep it in mind. In your output, you can explain. It's clear or not? Okay? This is the simple thing. Another one is called a standardized regression coefficient. That means y can be written as beta 1 x1 plus beta 2 x2 beta 3 x3. I standardize all the variables. Standardize all the variables. At the time, what's the meaning of my line passes through the origin? So there is no intercept is there. No intercept is there. So that's why beta naught is not away. So therefore, these beta 1, beta 2, beta 3 are called as standardized regression coefficient. With the help of the standardized regression coefficient, you can say which variable contribute more. You are having 10 variables in your model. Which variable contributes more? The next variable, which one contributes? These are the things you can identify with the help of your model. It's clear or not? So this is called as a multiple linear regression model. Now I am going to explain to you two problems. One is simple linear regression model, another one is a multiple linear regression model. You understand first, then ask many questions. Okay. Now this is the assumptions: normality, independence, linearity, homoscedasticity. So how to do it? In every PPT, I have given code. If you have forgot, go. What is the thing they are given? Click regression. Select linear regression under classical. Bring the dependent variable into dependent box, independent variable into covariate box. That's all. Is it clear? So now I am opening JAS. Now open computer, my folder. In the folder I am having one data, woman. So this is woman data. Both variables are scale. In multiple linear regression, your dependent variable should be a scale variable. Scale variable, okay? Now click regression. Linear regression. Linear regression. Dependent variable, bring dependent variable. Bring independent variable in covariate box. That's all. If it is scale, you bring here, or factors you bring here. Factors means nominal. Factors means nominal variables. It's clear. Okay. So if you want any, this is not necessary. These are all things are you want test, not necessary. Now this is my output. This is my output. You see that my capital R value is 0.995. So perfectly positively parallel. Positive parallel model. Then 99.1, that means 99.1% of the variation of the dependent variable can be captured by the independent variable. What is independent variable? Height. Clear or not? This is the things. Next one, adjusted R square value. Because if you have only one variable, so you take it as it is. So, root in my model, we can expect on average. We can expect on average the error will be 1.525. It's clear or not? I am predicting this is 1,000 rupees. The actual value of the item is 1,100. So what is the error? 100. It's clear. So in this model, you are taking only sample of the 25 individuals in particular class or particular area, particular things. So you are predicting the population. It's clear or not? So this is your output. The next one, this is called F value. You take F value and P value. So your P value is less than 0.001. Okay, your model is a test. Next. These are the things you have to write in your output. You see that here. This is beta naught. This is beta 1. You see that beta 1, it is significant. It is significant. So you don't take this one, this one. Okay? So this is beta naught, this is beta 1. So what is my model now? So how to write our interpretation now? So y equal to minus 87.517 plus 3.450. 450. Okay. So if you the new value x, you put x, then you will get some value. That value is the predicted value. So this is y hat. Y hat. Okay. So y hat equal to so and so, so and so. When you put x value, you will get y hat value. Clear or not? Okay. So this is beta naught something. This is standard error. So now this is we have only one variable. This is called standardized regression coefficient. So now the p value, that means I is significantly related with the dependent variable. Clear or not? So these are
So you are multiple methods.
that is the normal. That is the want to compare with the and automatically it shows it takes selection method. Okay. What's the meaning of forward? What's the meaning of backward means? If you are having the multiple independent variable, you apply all the variables. Which variable are insignificant and taking one by one. Finally, you will get one model. Backward method means you apply one variable. If it is significant, you keep it. You apply another variable. Then, if it is significant, you keep it. Otherwise, you remove it. So, this type of thing is called as a backward. So, this is stepwise. You can both are everything is same. That's not a big problem.
Then it's not intercept, we don't take it.
Which one? Intercept. This one.
First 136.7.
This is a base one. You don't worry about this one. You don't worry about this one. Okay.
Answer also.
Answer also the H1 only. This one only. You don't take this thing. These are not necessary. Okay.
So when we do regression, they ask like confidence interval 95%. So what does it mean?
95%
Confidence interval.
95% confidence interval for
They have the option.
yeah. You want confidence interval.
So what is it?
What is the mean? If you are not knowing the true population parameter, you can find with the help of our sample statistic. That is called as a 95% of confidence limits.
That means my sample size is 95% sure about the it can be represented as the population.
No. We have a chance, 95% of the chance, the parameter value lies between this range. That is the interpretation. We have confidence that 95% confidence interval. We have confidence that 95% chances for getting the value of the parameter mean.
For say in a particular so I am having 30 samples and getting average income as 5 lakh per month. So 95% of the chance of that average income of that particular area is
Will occur in this form. You listen. I will explain now.
So if you check U plus 2
Yeah. I will explain.
okay.
Yesterday I told you. So in the normal distribution, this is distributed normally. Okay. So you are assuming that your level of significance. This is called rejected area. This is the rejected area. So therefore, this is alpha by 2. This is alpha by 2. Alpha by 2 means you are taking alpha is a 5%. So therefore, this is called as a 1 minus alpha. When you are taking alpha equal to 5%, 1 minus alpha, what's the 1 minus alpha? 95%. 95%. It's clear or not? 95%. Okay. So now, already I told. Now, the probability of my absolute value is less than my probability of absolute value. This should be less than the small z. Should be equal to 0.95. So this is called 0.95. 0.95. That means what is the meaning of this one? This is probability. This is the answer. Coming, okay? What is the meaning of absolute value? This is I take z dash or something. Z1, okay? So z lies between minus z12 plus z1. Minus z12 plus z1. Okay? So these limits are called as confidence limits. But it's clear or not? Now you are having for test for single mean. For test for single mean. So what is the test for single mean? So what is the result equal to x bar minus mu divided by sigma by root n. Sigma by root n. So clear or not? Okay. So here you are putting this one when this is minus 1.96. This is plus 1.96 when alpha equal to 5. When alpha equal to 5%, the critical value, this is called as a critical value, the point. Clear or not? Okay. So therefore now probability of mod of z is less than or equal to 1.96 equal to 0.95. When I am fixing my level of significance alpha equal to 5%. Is it clear or not? Okay. Now you see that what is the mod of z? Not confident. So I am confident that the mod z value lies between so and so equal to 95%. This area. So what is mod of z? X bar minus mu divided by sigma by root n is less than or equal to 1.96. 1.96. So therefore this is x bar minus mu is less than or equal to 1.96 by sigma by root n. Sigma by root n, or otherwise you put x bar minus mu sigma by root n is lies between minus 1.962 plus 1.96. Okay, when multiplying this one, minus 1.96 into sigma by root n less than or equal to x bar minus mu less than or equal to sigma by root n 1.96. 1.96. It's clear or not? Okay. Now mu is my population mean. X bar is my sample mean. I don't know the value of mu. So now I am subtracting everything by x bar. Minus x bar minus 1.96 into sigma by root n less than or equal to minus mu less than or equal to minus x bar plus sigma by root n 1.96. Now I am multiplying both sides by minus. When multiplying both sides by minus, I'm getting x bar minus 1.96 sigma by root n less than or equal to mu less than or equal to x bar. This one I am multiplying both sides, x bar minus means this is plus, okay, minus minus. Automatically when multiplying minus sign, it is reverse. 3 is greater than 2. When multiplying this, minus 3 is less than minus 2. Minus 3 is less than minus 2. So therefore, it is reversed. Therefore, x bar minus 1.96 by sigma by root n, sigma by 1.96 sigma by root n. So therefore, the true mean of my population, I don't know the mean value of the population. With the help of the sample, I can tell. Okay, point estimation. Another thing is called as interval estimation. It's clear or not? So what's mu that can be obtained by x bar minus 1.96 sigma by root n, x bar plus 1.96 sigma by root n. Okay, when you go to the sigma, you can take it from the samples. So this is called as a interval estimation. Is it clear? Similarly, you want to find the 95% regression for that one means. So this is called, what I am putting this one, this is called standard error. Already I told you, standard error. So therefore, Z value is always beta hat divided by standard error of beta hat. So here you see that. If you divide these two, you will get T value. You take down the calculator type. This is beta 1 at. At means estimated value, not a true value. That's what we are putting at. Estimated value. Then this is standard error of beta 1. When you divide, you will get this value. But not this value, T value. Are you getting or not? This is called Z value or P value. Clear? So with the help of P, you can find the P value. Where it is nice. This is clear. Okay? So these are the things are expected in the model. Okay? Now how to interpret? So therefore, this is the things, how to interpret. I told you multiple R-square is a squared correlation between our actual and the predicted value. So on average, so F statistic tests whether the predicted variable taken together predict the response variable above chance levels. All the predicted variables are, predicted means independent variables, or contributes for my dependent variable. F test reject means any variable does not contribute for our model. Is it clear or not? So whatever the things I have. So these are the problem. Multiple linear regression, the same concept. So for multiple linear regression, I have another problem. To understand the concept, now all of you open the model. So you don't have data. State.excel. It is in the form of Microsoft Excel Word. That's why it not shows. What we have to do first? First we have to save this one in the form of CSV. While using JAS, how to save CSV? Clear? Okay. So if it is in another form, it will not show you JAS. So first I saved. Now you see that now I got states or not?
18.
Yeah, 18. Okay. Now I open. All of you open. So here I have so many variables are there. Many variables are there. This is the data collecting some information about the states. 50 states. their population rate, their income rate, illiteracy rate, life expectancy rate, murder rate, HS grade rate, frost rate, area rate. Here or not? So in your data, you are having so many variables are there. It's clear? Okay. So here, first of all, I am taking murder is my dependent variable. I am considering murder is my dependent variable, my model. So therefore, regression, linear regression, I am considering murder is my dependent variable. And I am taking population, illiteracy, income, and frost. These four are my independent variables. Clear? Is it clear or not? The same concept. So only one dependent variable, another four variables are independent variables. Clear? Okay? The same concept. Now just you put here. What is the RMSE value? 2.535. So in this model, my R value equal to 0.753. My R square value 0.567. My adjusted R square value is 0.528. My RMSE means error is 2.535. Why I am choosing means because we have so many variables. Some variables may be noisy variable. Noisy variable means that variable does not contribute for our model. Here or not? So this is my first model. Okay.
So which one is more important, adjusted or non-adjusted?
Which one?
Non-adjusted or adjusted? Which is more important?
Usually you are predicting multiple R square. Adjusted R square value, you see. Wait a minute. Okay, now this is my model. 0.7. Okay. Now, what is my F value? P is less than 0.001. No problem. So what about other? So you see here, the population. P value of income, P value 0.925. That means it is insignificant. What about frost? 0.954. It is insignificant. Among the four variables, two variables not contributing anything for my dependent variable. Clear or not? Dependent variable. Okay. So now I am going to do another model deleting these two variables. Is clear or not? This is called performance measures. These four variables are called as a performance measure. Which model is a best one? To select the best one, which one has a R square value or higher? That one you have to select. Which one has a error is the minimum? The model which one gives minimum error, that model is a best one. That's why I have written first model. Clear or not? Now the second model, I remove these two variables. What are these two variables? Income, frost. Income and frost. Yeah, area also. No. Income and frost. I remove all this. Population and illiteracy. I am having population and illiteracy. Now see, what is R value? 0.753. What is R value for second model? 0.753. What is R square value? 0.567. What is adjusted R square? 0.548. What I told, when you are removing the noisy variable, I will get the adjusted R square. So what is the benefit of adjusted R square? I will to keep the variable or not. That can be decided with the help of the adjusted R-square. What the answer or not? This is the thing. Okay. So now what is RMSE? 2.481. So this model gives the error more when compared to this model. It's clear or not? So therefore, the second model is the best one. So you keep the second model. Okay, I kept the second model. How to interpret it? So what's the things here? 1.652 plus 0.000242x1 plus 4.081 x2. 0. So therefore, y equal to 1.652 y at 52 plus 0.00242 x1 plus 4.081 x2. So this is population, this is illiteracy. This is called partial regression coefficient. This is called partial regression coefficient. What is the meaning of the partial? So we have two states. One state population is 1000, and the illiteracy rate is 3. Another one, population illiteracy. Another state, population is 1000, illiteracy rate is 4. You have to keep these things constant. I am increasing only one variable value. So what is the meaning of this one means? So therefore, if it is moderate rate is 8.5 or something, you imagine. Yeah. But so therefore, 1 unit increase in illiteracy increases model rate 4.081. So therefore, what is the value? Add 1, 3, 1, 12. So therefore, 12.131. That means it increases so and so unit. Clear or not? Okay? When you keep this one, automatically, whenever illiteracy increases, murder rate increases. Population increases, murder rate increases. It's clear or not? So now, the thing here, standardized regression coefficient. Standardized regression coefficient of population is 0.271. Standardized regression coefficient of illiteracy is 0.674. Which one is higher? Second one is higher. That means illiteracy. Therefore, among the two independent variables, illiteracy more contributes for the. This is the way you can decide which variables are more significant compared to other.
Illiteracy is coming as 0.6 R-square.
What is R-square means? It is for total model, not for individual variable. No, how it is?
Okay, what's R-square is coming as 0.43 in
Yeah.
that particular model. But in that particular model, significance of the variables are coming with significant variation.
Yeah, so you take it, not a problem. What I am getting now, only in multiple regression model. You are getting p value of the f test greater than 0.05. Then only you cannot apply multiple linear. Otherwise, you are getting this type of information only from my model. That's all.
First, the most prior thing is to take a p value.
Yeah, R-square, that's all. You go through review of literature, anything you go and check it, okay? It's clear or not? But if all the variables are insignificant, automatically your f value will be greater than 0.05. It's clear? So your f value is greater than 0.05 means here all the value are greater than 0.05. It's clear or not? So this is the way it's called as a multiple linear regression. So if you are having any doubt regarding the regression, I think I go. Okay. You are also morning class till now. You just verify. It's clear or not? So this is called multiple linear regression equation.
So the model we develop, we can dependent variable and independent variable. We can take the dependent variable, we can fix the dependent variable and dependent variable we can have. Say in the other model, if I fix my mother, I get so many. Murder is less than 5. So what should be my difference in the problem? I can calculate the
Order is less than 5 units for the dimension.
I'm asking, we have developed a model. So now we are predicting how much murder will be happening if the literacy.
Yeah.
So I am saying I want my murder should be less than this value. So I can say my literacy level should be what should be my literacy level that I must achieve. That I can say.
So here our model is here y equal to beta naught plus beta 1 x. You are telling my y value should be like this. So what's the value of x? But you are reversing, that is x on y. That's the two things are there. Regression equation of y on x. Regression equation of x on y. You are changing the variable. Dependent and independent, that's all.
From the developed model only, can I predict this?
How is this possible? How you can predict? Okay, so because you are predicting the value of y only from your model. So you are telling my value of the y is least one. Least one, you know. So otherwise you have to assume that write a program or something, this should be less than so and so. So what is the value of x? Then that time only you can. Okay. Clear or not?
So if you reverse it, then it will change outcome.
Outcome will be changed, definitely. Because
So we established a relation between X and Y here, and we say that if there are say 60 orders and illiteracy rate is increased by 5%. Okay. So if now I have a number of murders to be reduced, like 23 or 20, I need to find that the illiteracy will be reduced by some amount, right? So if I change, I put illiteracy as the dependent variable and murder as independent. So will it be true?
because in regression equation, mathematically, we have two things are there. One is y on x, another one is called as x on y. So y on x means y minus y bar. My regression coefficient, this is x minus x bar. You heard it or not? I don't know. So this is called as a regression equation of y on x. Y on x. So this is x minus x bar, bxy, and y minus y bar. This is the regression equation of x on y. These two are called as regression coefficient. Okay. When you are multiplying these two things, bxy and byx, you will get R square value. This is the property of regression coefficients. It's clear. This is a property. So what you are telling? So this is for what I did. If you want to find it, you use this one. Clear? Okay. This is what is the meaning of this one? This is called R sigma y by sigma x. This is the value R sigma x by sigma y. Standard deviation. Is clear? Okay. So these are the things you can expect from the multiple linear. Clear? Do you want logistic regression? Yes. So logistic regression means your dependent variable should be dichotomous. Dichotomous means you should have only two categories. You should code it as 0, 1. Coded as binary 0, 1. 0, 1, not 1, 2. 0, 1. Okay, the same like this. But is logistic regression. We have a same type of model, but we have probability of getting x against probability of not getting x. probability of getting X against probability of not getting X. Clear or not? Okay. So this is called log odd. This can be written as beta naught plus the same beta 1 x1 plus etc. up to beta n xn. So this is called log odd. When you want this one, odd ratio, you have to give exponential. You have to give exponential. Your dependent variable should be like this. Okay. In my PPT, so 50? 50? 15A, okay. 15A. This is the model. Okay, I've given everything. So this is what we did. Okay, this is the problem I've taken from internet. This is the problem given about student admission. Student admission. So 400 students are admitted in a particular college. We have the information of the 400 students. What are the information we have? One is GPA mark. Another one is what school he studied. Number 1 school, number 2 school, number 3 school, number 4 school. CBSE or state board or corporation. So also things are there, private school, number of school. Then another one is mark. Grade and mark and so and so. He is admitted or not? If he admitted 1, he is not admitted 0. Clear or not? Here my dependent variable is admit. My independent variables are GRE, GPA, rank of the school. GRA, GPA, scale variable. Rank of the school is a nominal. Clear or not? Among my 3 independent variables, 2 are scale and 1 are nominal. Clear? Okay. How to do it? So this is the things I have taken from the internet. Then I have given to you. Now you open logistic. This is logistic. Tick logistic. Click open. Okay. So therefore, admit is nominal. Admit is nominal. Nominal is dichotomous. 0, 1. So GRE, GPA, rank. Rank is also nominal. You can take it nominal. That's all. Okay. Clear or not? Clear? So now I have given everything in my explanation. Click logistic regression. What is your dependent variable? Admit. What's your independent variable? Covariate. GPA. So the rank you keep here. That's all. Now, from your model statistics, this is the these are so many measures are there in classification model. In the classification model, you have so many measures. That is ROC. ROC color, receiver operating characteristic. That predict which model is the best one. That is one of the measure. Another thing is called specificity, sensitivity, so on so things are there in classification. So leave it. Okay. Now. Hello? Rank the ordinal. But it can accept ordinal or nominal. Nominal, we can put it nominal, but it accepts. Okay. Breyer score, H measure, these are all measures. Factor. Scale value. Covariates are scale. Factor means nominal. Nominal. Factors means nominal. Okay. Nominal, here they are given ordinal, but it accepted, that's why I put it. Otherwise, you change it to nominal. Okay, let us try this. Okay. So these are all measures. Accuracy, AUC, sensitivity, specificity. These are all performance metrics. Performance odd ratio. We want odd ratio. Odd ratio. Odd ratio means confusion matrix. Confusion matrix. Confusion matrix. Whenever you are using the classification techniques, there will be a one matrix. That matrix is called as a confusion matrix. What is the meaning of confusion matrix? So, I tell you after the result. I tell you. Okay. Now, it's clear or not? What is it? Okay. Now, it is a regression model also. Now you see that these are all measures, leave it. So this is the estimation. Okay, this is odd ratio. Odd ratio 1.002. Hello? You have to see odd ratios only, not log odd. What is the meaning of this one? If one GRE increases, how to interpret? One GRE increases. I told you, multiple regression. You keep all other variables are constant, and you have to see the only one variable. If GRE increases 1 unit, the probability of getting admission against not admission increasing 0.002%. Okay, 1.002, you know. Okay, so GPA, if the 1 unit increase in GPA for any student, he will get admission 2.235 times more when compared to non-admitted students. It's clear or not? If what is the simple thing? If GRE is increases, admission chances increases. If GPA increases, admission chances increases. Clear or not? I given. Then rank 2, it is a factor variable. So I have taken, the software taken rank 1 as base variable. When compared to rank 2 student to rank 1 student, okay, go to see the odd ratio, you will get the chances 50% of the chance. 50% of the admission chance. Clear or not? So therefore, 3rd to 4th, 26. So what is the thing here? Whenever rank of the school he studied increases, admission chances decreases. Clear or not? Not clear. Clear or not clear? You see that? So this is the odd ratio. P divided by 1 minus P. P divided by 1 minus P. So what is the base? Base is the first rank. Okay? The second rank chance for admission is 0.509. Third rank admission for getting admission chances 0.269. Whenever rank of the school increases, rank means always 1 is the highest, but number, rank of the school increases, admission chances decreases. Clear or not? You can predict these things with the help of them. So therefore, this is called as a logistic regression. You see that I've given everything, whatever I'm telling, point by point. This is R studio, R commander. This one, okay, R. So you can test also. Therefore, you see that I'm taking every person as a same mark, same GPA, but they are studied in the different grade score. So first boy got 51% of admission. Second boy got 35%. Third 21. Fourth 18%. So therefore, rank of the school increases, the chance for getting admission decreases. Clear or not? Only that? Because you are not taking as a nominal. And voting nominal doesn't need it. Okay. Clear or not? So this is called, so I have given everything. The next one is called as a Poisson regression. Poisson regression means your dependent variables should be the count data. Count data. Count data means number of persons coming within these limits. Within 1 hour, 8 to 9, how many vehicles pass. So these are things is called as a count data. So your counting variable as keep it as a dependent variable. That type of regression is called as a Poisson regression. So they are same concept, but here Poisson distribution, e to the power minus lambda, lambda to the power of x by x factorial. That is called Poisson distribution. The lambda is a parameter. N into P in mathematics. Okay. You imagine lambda is the average rate. Average rate, clear or not? Lambda. So log lambda is my regression equation. So when exponentiation, you are getting lambda. Just like whatever we did now, no? So you see that the model. This is the model, log lambda, beta naught, beta 1, so on, so on. Okay? So here I have taken one problem. These are all from the internet only. Okay? So, admitted in hospital. So, for a particular patient, number of times network. How many times? Oh, okay.
Yeah, thanks only. Thanks.
Number of times patient visits. That is taken as a my dependent variable. Okay. What are my independent variable? My independent variables are, if you in the study school, number of years, then he has taken the insurance or not. Then these are all taken as our independent variables. Clear or not? Okay. So therefore, this is the things how to do it. Now, yeah.
Regarding this logistic question. So what we deal with in transport planning is like
What
we have
we-
4 modes, different modes,
Different.
travel modes like auto, bus, car, and two. So now what we need to do is like we have travel cost for each of the modes. Travel cost, travel time. So we need to find out what are the chances bus is selected, what are the chances auto is selected based on. So we need binary in that also.
So if you make it as binary, then go for logistic. If you are taking that as that is nominal, car, bus, so and so, 1, 2, 3, 4, that type of cases, you will go for discriminant analysis. That is one statistical thing is that. That is called as a discriminant analysis. So the same discriminant analysis also used for you have 2 cases also. At that case, that is different concept, not regression concept. That is you are discriminating. You are discriminating. That is called discriminant analysis. There is a linear discriminant analysis, quadratic discriminant. So many things are available. Okay, your dependent variable as nominal with more than 2 categories. Then you can go for discriminant analysis. Okay. Now here this is count data. I've given everything. Here count data. Okay. Now open computer. So therefore logistic Python. I think I have not saved in the SQL Excel form. Python. Yeah, Python. This is Excel. That's why word format. It's not shows. Save as. But I'm saving in the CSV format. Okay. So here we have so many variables are there. Each patient. Now, for the particular patient, the physician visits 5 times. Okay, so the hospital, which hospital is admitted? His condition is average, poor, or something. These are all nominal case. How many number of chronic conditions? If you have more chronic conditions, so then physician visit is more time. More time. Okay, it's clear or not? Data clear. Okay. Now, what I'm going to do now? Python. You see that here I am taking OFB of physician visits is my dependent variable. The other hospital, health, number of chronic conditions, gender, school, insurance taken or not, these are all I have taken as a independent variables. So therefore regression, you give generalized linear model. What's the dependent variable? OFD. What are the covariates? Okay, the factor, if it is hospital is a factor, you put here. Number of chronic conditions is a factor, put here. What are the things we are going to take? School, covariates. Okay, Praveen, how many insurance taken or not? You take here. Okay, here so many things are there, but you are going to health. I took or not. So here, if you are doing these things and using a link, not Poisson, you make it as a Poisson link. Poisson, automatically log. Okay, then you open, automatically you will get in values. The hospital type, when you are, it is not, I think, it is a scale variable, I think. Number of chronic conditions is also a scale variable. This is the only is nominal. Okay, we have to convert and do it. That's all. These are the things you will get. What I am telling you now, hospital, health is a nominal. Number of chronic conditions is a scale. Gender is nominal. Then other things are scale. Now you will get like this is R. What are the things are taken? ASP, health, chronic, gender, school, prevent. So then you will get like this. So with the help of this one, average number of visits for physician, you are getting like this here. This is this way. Now you see that number of chronic condition increases, expected number of efficient visit increases 1.158 times. Those patients are having more than one chronic condition, the number of visit increases. These are the things you can predict with the help of this one. So you see that you expect 11% discrete in the number of efficient visits for male group and compared to female group. So I have taken this one from this URL. Okay, if you type this one, you will get the same type of interpretation and everything. Clear or not? So this is called Poisson regression. Here, so we have completed everything. So 320. Okay. Finally, structural equation model. You need structural equation model. Do you know about structural equation model or not? You don't know. Structural equation model. That is the final thing you should write in your thesis. That is the final thing in your model. You are having so many factors. You are calculating the variable so many factors. For multiple linear regression, you are having one dependent variable, multiple independent variable. But structural equation model is the combination of multiple linear regression model. At a time, you can predict many models within one model. That model is called as a structural equation model. Clear or not? Okay? Right. You see that SEM models. Structural equation model is a multivariate statistical analysis to analyze structural relationship. It is a combination of factor analysis and multiple regression analysis. It is called sometimes called as a path analysis. Path analysis. Set of regression equations simultaneously we can do. So here, four symbols usually used. Circle. Circle is always used for unobserved variable. Unobserved variable means you are having EP1, EP2, EP3, EP4. Environmental perception you don't have value. You are taking the values from these three only. So therefore that is called as an unobserved variable. Square or rectangle always used for the observed variable. Observed variable means it is having in my data. Observed variable. A single-headed arrow. Why I am using single-headed arrow that represent regression coefficients. Double-sided arrow represent correlation or covariance. Okay. Okay. These are all things. Whatever I told, everything is available. So here, the such independent variables are called as exogenous variables. Dependent variables are called as endogenous variable. Observed variable, I told observed variable. Unobserved variable, error terms are unobserved. This is not available in the model. That is called unobserved variable. Just identify, over identify, under identify. That is means null model. All the variables are not correlated. That is called null model. Saturated model, just identified. I am having a three information. I am going to find three. So compromise. In mathematics, if you are having two unknowns, you must have two equations. At most, you must have two equations. X plus y equal to 9, x minus y equal to 8. Then only you can find the value of x and y. X plus y minus z equal to 8, x minus 2y plus z equal to 9. You are having only two equations, but you are having the three unknowns. At the time, you have to keep any one of the variables as constant, mathematics. Here, three unknown variable, you are having two information. So that is called over identified. These are the model. So in the putting the model, you have to assume variance of the any one of the factors should be equal to 1 or any one of the regression coefficients should be equal to 1. That is the thing you should do. These are all things, this is called just identified. When you want to understand clearly. So under identified, over identified, whatever I told you, no, these are things. Path diagram. Yeah. Here, this is where you got these factors in your model. Factors. EP, JS, SI, these are all called factors. Similarly, you are having factors in your model. So you are keeping your factors in somewhere. So you from the review of literature, you know an idea. So expectation is a dependent variable. These two are as an independent variable. So now this is one multiple regression. When picking this is dependent variable, these two are independent variable. This is another regression. So now loyalty is a dependent variable, satisfaction is an independent variable. That is another regression. So this problem consists of three regression models. Here are not. We can do it with the help of the structural equation. Here, Okay?
E3
Mama? Huh?
is not.
Yes, huh? E3. These are all error tag. I told you now. When regression, y can be written as beta naught plus beta 1x plus beta 2x plus error tag. Whenever the dependent variable occurs, there will be a error tag that comes. Linear regression, y equal to beta naught plus beta 1x plus epsilon.
Difference between observed and
Yeah, observe that is error tag. Because this is the dependent variable. This is the dependent variable. This is the dependent variable. This is the dependent variable for this variable. This is the dependent variable for these two variables. This is the dependent variable for these two variables. Clear or not? Okay? So this is called structural equation model. How to do it? So from the SI, these are we can done with the help of the SIM model. This is called SIM. So how to do it? I have given everything to you. So you have to write the command. Simple command, not a big one. Because these are the variable names should be available in your data. Variable names, because case sensitive, or is a programming language, case sensitive. So therefore, the same name you have to clear. Okay? Then you can take it output. So I already told about confirmatory factor analysis to you. So this is the confirmatory factor analysis, how to do. Already you did it. So therefore, these three are measured variable. This is latent variable. So therefore, up to this part is called measurement model. Measurement model. So when you are connecting the unobserved variables, that is called structural model. That is called structural model. Now, yeah, I already told these are the fit measures. Fit measures. This is our 11 package. CFA, how to do CFA. Everything, okay. So this is the things I have taken. That's why I have given also. This is a simple linear equation. Can be found with the structural equation model. Okay. Now open JASP. JASP. Open SIM model. Okay. So loyalty to make it assess slow. Just you draw a diagram. Trial and error method. You don't know about, you have information about each factors. But review of literature, you know about effectiveness of each factor. Depends upon your study. Clear or not? That way you are connected. That way you are connected. Now I am connecting. Yes, expectation is a dependent variable for purchase and perception. Satisfaction is a dependent variable. Now you go for SIM, structural equation modeling. Here you type purchase, no, not purchase. What is the dependent variable? Expectation. X, the same word. Till dot, this symbol, till dot. Purchase plus perception. Just you are giving like this. Next one, expectation gives satisfaction. Expectation gives satisfaction. So satisfaction is my dependent variable. Expectation is my independent variable. Okay. Next, loyalty. Loyalty is the dependent variable. satisfaction is independent variable. Okay, you have to type independent variable right side, dependent variable left side. Clear or not? Trial and error method only you have to try. Model. You build model. Final model is the one. I told you the fit measures. Whenever your model satisfies all the fit measures, then you can take that model is your model. Clear? Then you have to interpret. That's all. Finally, that is the final structure in your thesis. Whenever you are presenting your thesis, this is the final. Clear? Now, how to run this one? You copy and put, or otherwise, before that, output. Additional fit measures, R square value, path diagram, standardized estimate, show path estimates, modification indices. This is enough. Modification indices. Okay. Now, what is my output? So I didn't run, You copy, control, enter to apply. Control, enter. Control, enter. You see that? This is my model 1. I told you chi-square value divided by number of degrees of freedom should be less than 5. P value should be greater than 0.05. But here it is greater than 5. It is not less greater than 0.05. So you should go for modification indices. Hello? Going error means you mistakenly type anywhere expectation. You may miss the E or C or something, or you may type with capital letters or something. Right or not?
The data type has to be changed.
That is loyalty or change as scale. Loyalty you change to scale. Anyone got it or not? You got it. Okay? Got it. Okay, now I told you no, CFA value should be greater than 0.9. But this model does not satisfy fit measures. So if it is not satisfied fit measure, then we go for CFA. What we did? Modification. Modification indices tells about you connect satisfaction with perception. You connect satisfaction with the perception. So therefore, which one? Satisfaction should be dependent variable. Perception is the independent variable. Okay. Satisfaction, perception. You copy this one. Copy and click second model and paste. Paste. Oh, I paste 2 times, Okay, this model. You copy and paste. Or otherwise, you type again. Yeah, paste. Yeah, paste. Okay, copy and paste. What are the things we got it? Satisfaction is my dependent variable. Satisfaction is my dependent variable. Perception is my independent variable. This is my second model. Okay. Now I apply control enter. So you see that AIC value of the second model is least when compared to the first model. Acquired information criteria. That is one of the measure. BAC is the meaning of Bayesian information criteria. That is also should be less. Which model we are having the less value, that model is the best one. Now, you see that the first model, chi-square chi-square value divided by 4. You are getting less than 5 or not? Less than 5. What is your p-value? 0.102. It is greater than 0.05. Clear or not? So it satisfies the criteria or not? Clear or not? Satisfy the criteria. Okay. So 0.8. My second model is the best one. Okay.
So chi-square is 7.7.
Yeah. Okay.
More than
Copy and paste. Copy and paste. How to interpret? I have given interpretation also. You see that SEM and CFA, the structural equation model. These three are independent variable, dependent variable. These two are independent variables. This is error. How many variables are there? This is the model. This is the diagram got from the AMAS. You take, remove this one and put it your gas diagram. Okay. What is the meaning? 1 unit increases in purchase intention. In the both two variable which contributes I, that means expectation, purchase intention contributes I compared to perception, because the standardized value for this one is higher. Clear? So I have given everything. Yeah, please. So it satisfies all the criteria. So similarly, I told you, correspondence, confirmatory analysis. You have to do like this. So this is construct validity and reliability. Okay.
We have only one access point in this room.
Connection is good. It's not good.
While server sharing, data got bandwidth got used.
You see that this is called modification indices. Okay. So therefore now modification indices in the first model, it gives it shows when you are adding satisfaction to perception, it increases modification indices. This concept we took. Okay, so that's why we are added this equation to the previous model. Clear or not?
higher modification is value.
Okay, previously this is purchase, this is perception, this is expectation, this is satisfaction, this is loyalty. Okay, this is the first model. What is the modification indices? You also connect this one with this. So now this is the second model. So this is the whole blueprint of your thesis. Clear or not? So this is the way, this is called as a structural equation.
Even if I make a trial one, you have to assume that these are the dependent variables and the relationship. And after the trial one, we will get to know the
Yeah. So trial and error you are doing now. Finally, it gives the perfect model. That is true.
For whichever this MI's value is more, we should try to.
Yeah, we should try. Which is the more. This is given in a descending order, you know. So you take this first one. You try it. You're not possible, you try it. Add. In the Amas, you will do like this.
But now for the new models also we have got some modification indices. So we also take that for when to stop.
Because it is only 5. It is only minimum 5 only. Okay. So otherwise if you add it, you will get better mark. Because it satisfies some criteria, it measures. In the previous model, it does not satisfy the chi-square value divided by real circular less than 5. But now it satisfies. That's why I did.
So this is the minimum satisfaction we can get.
Yeah.
If we add more, we can get.
What are the things? Yeah, don't worry. What are the second model gives? We will try it. Okay, what's the second? Yeah, when you are adding loyalty, expectation. Loyalty, expectation. This is the first one, you know. Loyalty, expectation. And that means you have to give expectation and here exception. Okay, so this is the third model. Okay, you see that root mean square error is 0, no error.
Then we will stop. The error is
No, we will stop but because you have developed another model. That's all. You will see that, but it is decreases. AIC also decreases. BIC also decreases. Few. Okay, clear or not? What is that? So root mean square decreasing. CFA value. The CFA value it comes to 1. Increases.
Which one we select?
Finally select third one. Third one is gives least one, you know.
error is the
Yeah, error, not only the error. CFA value also come to one stage. Okay. So now you see that loyalty R square value increases, AVE. These are the things you have to. Okay. So what is the modification indices? Anyone? No modification indices, you know? Where? Model 3 part
Perception satisfaction.
is for second one, but model 3 no. Model 3 no modification indices.
What's the
Or otherwise we take. Yeah. This is modification model 1, you know, model 2, but model 3 we don't have, I think. Yeah. So it is reduced to 1.955. Okay. Clear? Whenever you got quick measures, you can stop.
And follow the model.
Yeah, farming
So
model.
the best relation, like within which variable will give us the output.
So if you look at the diagram, outside. So what are those values in the diagram?
Oh, values. Some are, what are the values in the diagram? You know, right? You see that. This is called covariance. Covariance between these two. Because it is greater than 1. No. Correlation means it lies between -1 and 2 plus 1. It is covariance. Unstandardized regression is covariance. So this is regression coefficient. This is regression coefficient. This is called variance. Variance. Okay. This is regression coefficient. This is regression coefficient. Clear or not? Hello?
Yes.
So when you are using when diagram, in the diagram, you are mentioning show legend means the source legend. Standardized estimates. That's also you got it. Standardized estimates. It's enough. So this is called standardized estimates. Hello? These are all called standardized estimates. So the very easiest method, the copy and paste. After last question.
Last,
Huh?
model 3 sentence can you solve?
Model 3.
Like diagram can you solve? So what should be the final equation output from this particular?
Yeah, that is the only, this is you got it now. This is the diagram form. In this, you come here, this is modification indices. Yeah, this one. This is the regression coefficient, expectation. In both, these are dependent variable. These independent variable. Okay, so in standardized, purchase contributes more than perception for expectation.
Because AI has the coefficient.
Yeah, all. This is all. All. This is called all. All is called as a regression coefficient. Standardized regression coefficient.
So that is that multiplied by that particular variable.
Yeah. What I told you, 5 independent variables are there. You are getting standardized regression coefficient for 5 independent variables. Which variable has high value? That contributes more. Here you see that these two expectations is a dependent variable. Purchase and perceptions are independent variable. Okay? For expectation, which variable contributes more? That can be predicted by this one. Clear or not? Okay? So now, 1 unit increase in purchase increases 0.24 units. This is called unstandardized. Okay? Right. So now satisfaction, expectation, perception. Which contributes high? Perception contributes high. Loyalty, satisfaction, expectation. Which contributes high? Expectation. All are significant, but here these two are not significant. These two are, you see that, these two are not significant. That's why these things not necessary. Clear or not? When loyalty, you cannot add satisfaction and expectation. But 0.16, this is significant. But this is not satisfaction to loyalty. Clear or not? Fine. Fine. Okay? So up to this, within 1.5 days, I completed more with your help. 14 minutes.
We covered so many topics. But then it was okay.
Okay, because I have given information, that's all.
Yeah, because your files also have a lot of information.
You take few, that's okay. Okay, I have given notes also. I have explained all the things, whatever I said it, I have explained.
That is the reason we are not here. But all the information and the folder.
Oh, even the folder, even they are asking questions.
Yeah, definitely.
So,
Definitely.
even I didn't consider this one for past 6 months, then I will forget this. Yeah, that's right.
Please, if you have any questions, discussions, you can do. He will come in some 2-3 minutes.
You can take that. Take out.
5 minutes.
Okay, this one.
Yeah,